Okay, very good. Good afternoon, everyone. My name is Duncan Brown. I'm Assistant Chief Plan Examiner for Energy Code Compliance with the New York City Department of Buildings. And presenting with me this afternoon will be Jean Kim, who's also an Assistant Chief Plan Examiner in our unit. So Jean and I will be doing the presentation and then helping out with the Q&A. We have our Director, Emily Hoffman, and the other Assistant Chief Plan Examiner in our unit, Bruce Cale. They'll be helping out with any Q&A that you have during the course of our presentation. Next slide, please. So this presentation is available for AIA credit. So next couple of slides are the standard slides associated with those presentations. Next slide, please. Copyright information. Next slide, please. The course description. So the idea this afternoon is that we're going to be talking about the 2020 New York City Code, and in particular, the how-to guide that's available on our website. We want to cover a couple of topics that we think there are common questions about. We're going to be looking at some of the new envelope requirements, and then mechanical and lighting control mandates. And then just at the end, we want to mention briefly the new buildings bulletins that also cover the, some of the changes related to the current version of the Energy Code. So the website links are there at the bottom of the page. I'll not try reading all those out, but take a snapshot and you can look at those later. Next slide, please. The learning objectives are here for the AIA credit. Next slide, please. So first topic that we want to cover are spandrel panels. And documenting spandrel panel requirements was a new addition to the 2020 code that we wanted to cover briefly. So next slide, please. Spandrel panels, loosely defined, would be the opaque part of a curtain wall system or the opaque part of a metal framing system. It could be back-painted glass, then stone or metal. Now, not metal panels as such, but a sheet material within a frame. So these wall type areas should be entered into ComCheck as part of the opaque wall rather than the fenestration. So that's the big change to note. To do that, the new code added a table C402.1.4.2, that helps you select your spandrel type in order to enter the values into ComCheck. So the ASHRAE Appendix CA has the equivalent table 5.5.3. So you have to select either the frame type between aluminum without a thermal break, aluminum with a thermal break, structural glazing, or then continuous glazing. Once you've done that, you then go on to pick the panel material, whether it's stone, metal panel, or then a form of glass. And then you select, based on that, you know what your R value is of the insulation that you have between the framing members, and that would be the value that you enter into the ComCheck. So on the next page, we have a generic spandrel panel, and for the purposes of example, let's say this is aluminum with thermal break. Then looking at the arrows below, that would be aluminum with a thermal break, and then we'll say that it has double glazing with no low E coatings, and then the 6 inches of mineral wool with an R value of R.42 an inch would give us an overall R of R25. And that in turn would give us a U factor of 0.151. And that's the value that we would enter into ComCheck. So on the next slide, please. So just copying that down from the last page, here's the aluminum with thermal break and the double glazing with no low E coatings and the R25 of insulation. There's the 0.151 value. And then using the other steel framed wall type in ComCheck, that would get entered in as part of the opaque wall area with the value of 0.151. And then in the bottom panel, this is how that would appear in your actual ComCheck report. So next slide, please. So if your wall construction doesn't fall within that table, then documentation using a program like Therm must be used. So if your insulation is less than R4 or your spandrel panel includes a backpan, then Therm documentation would be required. Next slide, please. So air leakage testing and the air barrier continuity plan is another topic that we have frequent questions on for the Energy Code technical email. Next slide, please. With the 2016 code, it was pretty clear that all residential applications required air barrier testing, or also known as the blower door test. However, the testing requirement for commercial buildings in the 2016 code started at 25,000 square feet or greater. With the 2020 code, this was reduced to 10,000 square feet and greater. And then, whereas the buildings from 25,000 to less than 50,000 that were taller than 75 feet were excluded from the requirement in the 2016 code, in 2020, buildings 10,000 to less than 50,000 square feet that were taller than 75 feet were required to do the visual inspection and then the air barrier continuity plan if testing if they preferred. So what does that mean for TR8 inspections? There's a great summary table in the building's how-to guide on page BE8, and on the next slide at a slightly larger font, I'll run through that. Next slide, please. So for buildings, this is commercial buildings and under 10,000 square feet, they just require a visual inspection. And then for buildings greater than 10,000 square feet and less than 50,000 square feet that are also less than 75 feet high, that's to say 7 to 8 stories high, they require visual inspection and testing. And if they're a building of that size and they're R2 occupancy only, then they also have the option of sampling or unit testing. And that's covered in the residential code under R402.4.1.3 and also 3.1. So for buildings that are greater than 10,000 square feet and less than 50,000 square feet that are greater than 75 feet tall, that's to say taller than 7 or 8 stories, then they are required to do the visual inspection and ABC plan, or they have the option of doing sampling if it's a residential building, or testing if they would like to do that. And then moving on to the last section, where for the buildings greater than 50,000 square feet, they are required to do the visual inspection and ABC plan, and also they have the option of sampling or testing. And the numbers below there, the 2A6 and 2A8 or 2A7, those numbers refer to the TR8 inspections that are on the TR8 form and are typically checked. Thank you, Gene. The air barrier continuity plan is another topic that we have frequent questions on for the Energy Code technical email. We are actually going to be posting a more specific set of guidelines developed by our inspections team, along with a video about air leakage testing in the fall. So what do you need to have on the drawings? Details key to the thermal boundary of each unique assembly, joint, seam, and penetration. I think people are pretty familiar with the details that are available online and widely copied, but what we really want to see are the details and keying that is project specific. So not just the ones that everybody seems to copy onto the drawings, but you have to make it really project specific. Then also the specifications of sealing and remediation procedures. So although the project specifications will likely be much more detailed much like the key details, the intent here is almost like a table or a checklist for locations to seal. So you tape at the insulation, silicone window frames, gaskets of doors, just sort of a checklist of those kind of things, and what the sealing method is going to be at those locations. The other two things listed here are the testing inspection standards for each unique assembly, and then the sampling protocol. So broadly speaking, ASTM E1186, air leakage site detection in building envelopes and air barrier systems, covers most of the requirements for testing and sampling protocols related to the ABC plan. And then the information, and I'll refer you to this more directly, the information that is going to be posted on the web in the fall will cover the requirements for the reporting guidelines in detail. Although there's not an equivalent table for commercial applications, the residential table R402.4.1.1 would work well as a template for the ABC plan requirements, with additional columns being added for testing and sampling. Next slide, please. So a new requirement for the 2020 code was air barrier commissioning for buildings 10,000 square feet and greater. So these are smaller buildings than people anticipated before, and they may not require the full documentation of an ABC plan, but still require some of those items. That's to say that detailed components, the field inspection checklist, and a note as part of the commissioning statement. So does this mean that smaller applications require commissioning envelope? Sorry, the commissioning agent for the envelope? So next slide, please. This is a common question for the Energy Code email. And the response is that what somebody called tandem commissioning would not be required as long as there is documentation of the details, completed field inspection checklist, and detailed TR8 inspection reports, and then a report to the owner indicating compliance. Next slide, please.
So I could jump in now.
Yep.
My name is Jean Kim. So I will be one of the presenters today. So like SPANDRELS, thermal bridges are one of the new requirements first introduced to the 2020 NYCCC for the building envelope. The importance of mitigating thermal bridges in the envelope have long been discussed, but in the 2020 NYCCC, it has become the first language of its kind that made into a US Energy Code. The thermal bridge requirement applies to both residential and commercial. So you see these definitions in R2 for residential building and Chapter C2 for commercial building, and you will also find exact same definitions in section 3.2 of Appendix CA, which is modified ASHRAE 90.1 2016. And just a side note that if you look at the hard copy binder codebook of 2020 NYCCC, you will see the sidebar NYC indicated. This normally means this is a substantial change found in the 2020 NYCCC from the 2020 New York State Energy Conservation Construction Code, 2018 IECC, and ASHRAE 90.1 2016. And like I said, the thermal bridge requirement is found only in the 2020 NYCCC and not in the model codes. The code sections, now we are looking at it, the residential to the left and the commercial to the right, they're almost exactly the same, except that the size of the point thermal bridges that must be noted. And in the linear thermal bridges, you will see the scope of the default side values in the two tables are different. You'll see in the next slide here. So again, to your left, this is a residential section. default side values of the average side values of the unmitigated linear thermal bridges. And to your right top is the ECC, and this is from ASHRAE. So if your building has any of these thermal bridges, balconies, intermediate floor slab edges, parapets, and etc., their building bridges and their building bridges are normally not completely mitigated. So you use this table to identify their side values per the bridge type, and we need to report them in tabular format. Just one thing to note that residential section table has a separate set of side values for the wood framed construction. And now you're looking at the how-to guide page BE9, building envelope page 9. So this page summarizes the brief definitions, the typical assemblies, and the sample illustration, and the document requirements to fulfill this code section. And note that this is all mandatory for residential and commercial buildings. And also this applies to new buildings, additions, and also any alteration work that impacts the building envelope. So we saw this guide in the fine print. If you go back, these average side values are derived from the BC Hydro Building Envelope Thermal Bridging Guide version 1.2. So if you look at the cover of this guide closely, a lot is going on the building envelope and its thermal boundary. And maybe we could use this to identify those 3 types of thermal bridges with some assumptions, focusing on maybe here and here, this area. So first, clear field thermal bridges. Any typical walls, maybe even columns and soffit, and the spandrel walls. So if you go back, this is definitely a spandrel wall. So it's opaque wall. So it's not fenestration. So it's spandrel walls. And so these are the vertical components, but not only that, the roof and any slab components, they are normally clear field thermal bridges because they are normally interrupted by structural framing, or they're compromised by other assembly components. And all these clear field thermal bridges, they're typically accounted for in the assembly U factors that are derived from ASHRAE 90.1 standard Appendix A. For example, steel framed walls, structural deck roof, mass floors, and etc. Moving on to linear thermal bridges. So I highlighted in blue here, where vertical walls meet the roof, intermediate floor slab edges, and the slab balcony connection areas here, and possibly where the walls meet the overhanging slab above. So I indicated as a band, but just be careful that linear thermal bridge is a length-based thermal transmittance. So it has the length value, not the surface area value. Another major linear thermal bridges I highlighted separately, they are fenestration perimeters. So all windows, the balcony full height glass windows and doors here, and the storefront windows, all these perimeters are the linear thermal bridges. And for buildings with substantial window to wall ratio, the fenestration perimeters easily become the longest linear thermal bridge type in the building. And slightly off the topic, a little beyond the NYC, if you design a building with passive house standards, all these linear thermal bridges are taken into account when calculating the annual heating demand and heating load of the building. And that will probably be the future of NYC as well down the road. Lastly, the point thermal bridges. This is just based upon our assumption that these timber wood beams are some structural members penetrating the insulation layers in the soffit area. So this could be point thermal bridges. And these are area-based thermal transmittance. So it has the square foot of value in the denominator of the measurement unit, the chi value. Now we are looking at BE 10, building envelope page 10. This is a suggested documentation of each thermal bridge in tabular format on drawings. Again, the main intent for this new code section is for applicant to understand where in the proposed building envelope these thermal bridges occur, like the walls, some point thermal bridges, and here in this linear thermal bridges. So you have to understand where they happen, where they occur, and then acknowledge their presence and report them in these categories. And especially for linear, the linear thermal bridges, like we discussed earlier, we need to declare the psi value per the bridge type using the values given in the tables we saw earlier. Just note that all thermal bridges, whether unmitigated, partially mitigated, or completely mitigated, they all must be noted or documented per this code section. And these psi values, those values in the table we saw earlier are based upon poor performing details. So if you have some mitigated thermal bridges, you have a better alternate psi values other than those in the table. You can declare those values here, but we'll need some justification, some supporting documentation of your details and psi value or U factor calculation. And now let's move on to the energy truss. Oh, before that, I have another. This is the thermal bridges in balcony slab. How you identify them, how you report in the envelope com check. So section 1 is with the structural thermal break here, and section 2 is unmitigated linear thermal bridge. So if you have this R7.2 structural thermal break, you can, in your envelope com check, you can report that as a continuous insulation R7.2, and you could get a little credit here. But if you don't have any structural thermal break, you can only report this area as it's a basically 12-inch thick wall if you look from the outside of the building. So you say solid concrete 12 inches thick, and there is no insulation whatsoever. So your U factor gets much worse than before without the structural thermal break. And I want to recommend to check out, this is B11. So if you go to our how to guide BE4, it prescribes how the continuous insulation in balconies and parapets to mitigate the linear thermal bridges. Let's go over this residential section really quick because I spent too much time on the thermal bridges. So this is another new concept, new section. I don't think this is new. I'm sorry. I'm going to take it back. So this section is only for residential, the energy truss, and the section will be very brief. The studies suggest that we lose much of the heat in our homes through the roof. So the hot air rises and they're trapped under the roof. And homes normally have relatively higher surface ratio of roof than commercial building. So the roof and the attic areas are not properly insulated. About up to 25% of all heat may escape the roof. So 2020 NYC ECC requires R49 insulation in wood framed roof construction. The equivalent U factor is 0.062. And if the roof's construction is still truss construction, R38 cavity insulation plus R5 continuous insulation assembly will satisfy the requirement. So this R49, how they should be installed? The table R402.1.2 specifically requires R49 in climate zone 4, and this section illustrates R49 cavity insulation in standard truss roof construction, where it is practically challenging to maintain the full height of the R49 cavity insulation near the top plate of the exterior walls meeting roof rafters. So this section suggests raised hill truss roof construction. This allows for substituting R38 or R49 insulation to meet the requirements of the code, provided that the reduced R38 can be installed at its full thickness, uncompressed over the plate line of the exterior wall. So all this is summarized on BE 17 page. The summary here, and this is the illustration, the same illustration for the raised hill truss. So I think that was the last page of my energy truss. Back to you, Duncan.
So yes, we also wanted to talk about the ventilation system design, in which are residential specific requirements for the new energy code. Next slide, please. So although the 2014 New York City Mechanical Code does not have this requirement, the 2012 International Mechanical Code and later versions require that when buildings are tighter than 5 air changes an hour, mechanical ventilation is required. The New York City Energy Code requires residential buildings to not exceed 3 air changes an hour, and therefore the trigger for mechanical ventilation requirement comes into play relative to the IMC. So as homes become tighter due to the increasing stringency of the energy code, ventilation becomes more of a concern as less air is transferred between the leaks within the structure, and inadequate ventilation can lead to comfort problems, humidity, and mold developing. Next, please. Next slide, please. So in terms of the how-to guide, we lay out that for ventilation, dampers are straightforward and typically provided as part of mechanical equipment. Fan efficacy is also straightforward to document, but the more difficult issue is the ventilation system design. So in new residential buildings, exhaust-only ventilation is no longer accepted for the energy code compliance. Instead, the ventilation system of every dwelling unit must be designed with a supply and exhaust ventilation system with a heat recovery ventilator or an energy recovery ventilator. Or, and the last point B there, a balanced ventilation system satisfying the airflow rates and fan capacities in the code is also a possibility. But we're typically not seeing many people able to satisfy the requirements of those tables. So what's the difference between an HRV and an ERV? HRVs and ERVs are heat exchangers that take heat from stale exhaust air and use it to preheat incoming air. This saves on the energy and expense required to bring up the incoming fresh air to the required indoor temperature. So the primary difference between the two is that an HRV transfers heat, while an ERV transfers both heat and moisture. Next slide, please. So how might you typically document compliance? Well, here's a very schematic example of what might represent good documentation. First, on the top left there's a riser diagram with the ERV clearly shown. And then in the small plan, there's a ductwork schematic where the ERV and there's a blow up can clearly be seen. And of course, there's an equipment schedule with the ERV or HRV clearly specified. And it helps if you can sort of really identify that on your drawings when you put that in your schedule. Sometimes just it won't be clear from a manufacturer's name or spec that is in fact an ERV or an HRV. Next slide, please. So we're also going to talk about economizers very briefly. They were a big part of the 2016 code that people had a lot of difficulty complying with. And the 2020 code, this was updated to be less stringent for residential buildings. Next slide, please. So with the 2020 code, with the 2016 code, the limit was 300,000 BTUs. And then with the 2020 code, this changed to 1,500,000 BTUs for residential buildings. Next slide, please. So as a brief example, with the 2016 code, the limit being 300,000 BTUs for residential. Let's imagine a typical PTAC or a heat pump that was 12,000 BTUs, or like 1 ton. Then dividing the 12,000 into 300,000, the limit, that would give you 25 pieces of equipment. And let's say it's a 1-bedroom apartment. That would basically be a 12-unit building. With the 2020 code, with the limit raised to 1,500,000 BTUs for residential, with the same PTAC heat pump size, you can now have 125 pieces of equipment. And at 2 pieces an apartment, the living room and the bedroom, that would mean a 62-unit apartment building. So a much bigger increase. So also to note that for split systems or VRF systems, the indoor cooling capacity has to be used to calculate the total supply capacity. And the limit there is 270,000 BTUs per individual indoor unit without an economizer. And so the example in that case, where the typical unit is 5,000 and dividing that by 1.5 million, that becomes 300 pieces of equipment. And at 2 pieces an apartment, that also means 150-unit apartment building. Next slide, please.
So lighting controls, they are pretty extensive and complicated requirements in commercial buildings. So today we'll take a look at just a few pages in the how-to guide and check one of the email inquiries we received through the Energy Code technical email account. On the page 3 of lighting and electric power section, LE3, we summarized occupant sensor controls, where occupant sensors must be provided and how they must function to automatically turn on and off of the lighting depending on the area and use types. And we have a separate section for the open plan offices, cafeteria, and fast food dining areas of 300 square feet or greater, and another separate controls section for egress illumination. Page LE4 focuses on time switch and light reduction controls, where they are required and what specific functions must be programmed into the time switch controls. And light reduction controls are often called bi-level lighting controls. And there are 4 different ways of fulfilling light reduction controls, as we illustrated on this page. So the first option is to make all lights dimmable here, and then connect them to a dimmer here. And then second and third options are alternating fixtures or lamps, and group them to 2 separate circuits and door switches, so that you could reduce the lighting level of the room evenly. And the last option is just switching each lamp and luminaire. Then it will be more than bi-level lighting controls. Page LE5 lists where time switch controls are exempt and where light reduction controls are exempt. And I'd like you to note that all these pages, we focused on ECC section because there is slight difference between ECC and ASHRAE. So we based on ECC for most of this lighting controls section of the how-to guide. So here with a little asterisk, we put a note that if your compliance path is ASHRAE 90.1, you better go to the section and check the table directly because the table in ASHRAE, this is one of the like sample table 9.6.1. So while lighting control provisions in ECC are rather descriptive, ASHRAE has listed the controls requirement in this nice tabular format, space by space. So with ASHRAE, it's relatively easier to identify what kind of controls are required in particular spaces. So lots of information are packed in this table. So a little later, we'll go over briefly how we use this table for controls requirements. Now let's jump to a lighting control question we received through the Energy Code email. So this question is about open plan office areas manual control. It says in 2020 version, open offices, cafeteria, dining areas, and fast food dining areas need to meet section C 405.2.1.3, but does not say they need to meet items 1 to 3 under C 405.2.1.1. Occupant sensor controls for all other spaces specified in section C 405.2.1 shall comply with the following. There is nothing about manual controls in C 405.2.1.3. So is this interpretation correct? So we'll go straight to this section and see what it says. So if you pull up C 405.2.1.1, this section actually points the other section for open plan office areas of 300 square feet or greater. So this means open plan office areas of less than 300 square feet in area, they must comply these sections. And one of the requirement is they shall incorporate a manual control. So open plan office areas less than 300 square feet, a manual control is required. And this is the other section that the previous section pointed to. According to this section, the open plan office areas of 300 square feet or greater, they must comply with all of the followings. So if you look at it, it's talking about maximum control zone size, 15 minutes automatically turned off, and minimum 80% of the full lighting must be turned off in 15 minutes of non-occupancy. And this is about daylight responsive control. So it looks like there is nothing about manual control for these larger open plan office areas. But if you keep going down in the code, there is a C405.2.2, and it says the area not provided with occupancy controls complying with this section shall be provided with this time switch control function. And the open plan office areas of 300 square feet or greater falls into this category. So according to this section, these larger open plan office areas must have time switch control function. And one of the functions include an override switch, and that should come with a manual control. So the bottom line, the open plan office areas, whether smaller or larger, they both require manual control. And we could compare this with ASHRAE section. Like I said, ASHRAE has this controls requirement nicely formatted in table. So for offices, open plan less than 300 square feet or 300 square feet or larger. So their requirements here in ASHRAE are almost identical to the ECC requirements. Just note that the difference between the two different size open plan areas. The smaller open plan office area, general lighting must be automatically turned off, 100% full off, within 15 minutes of all occupants leaving. Whereas the general lighting in 300 square feet or greater must be automatically reduced at least 80% for ECC and at least 50% of the full lighting power for ASHRAE in 15 minutes of no occupancy. So I said here, so for these two different size open plan office areas, the comparable ECC sections are found here, and they're almost identical. Now, let's jump to residential code section. And this electric vehicle service capable requirement, this is another new section first introduced in the 2020 NYC ECC. The code section is pretty simple and straightforward. So we summarize it with a nice photo here on other requirements, page number 7. So this is only residential. And this requirement applies to 1 or 2 family townhouses or low-rise multifamily buildings with parking area. So what's required is for each dwelling unit, we must provide 208/240 volt 40 amp outlet or panel capacity and conduit for future installation. And 1 per each is those smaller scale dwellings. But if it is a large residential occupancies with a common parking area, what is required is that 5% of the total parking spaces, but not less than 1 outlet. So let's say this common parking area has 30 parking spaces. Then the 5% of the 30 parking spaces would be 1.5, right? So is it 1.5 or we compare 1.5 or 1? So 1.5 is bigger. So this 30 parking spot communal or common parking area is required to have at least 2 outlets or panel capacity and conduit for the future installation of 208/240 volt 40 amp outlet. And it's time to jump to those questions we received through the Energy Code email. And this is a scenario we received through the email. So I'll read it quickly. So a new detached 1-car garage built as accessory to a new group R3 single-family detached residence. The garage has no lighting fixtures, no electrical outlets, no wiring for future lighting, heating, or motorized overhead door, and no electric panel is installed in the garage. So in this case, is compliance with the electric vehicle service capable requirement, is it required? So it looks like no electricity use, nor wiring for future electric power use is intended. No lighting, no cooling. So the garage is definitely a low energy building, which will make it exempt from energy envelope requirements. So then is compliance really required? The answer is yes, the requirement applies. 1 or 2 family dwellings and townhouses with parking area provided on the building site should provide this outlet. So this R404.3 applies regardless of whether electrical wiring for the parking space is intended. And this 404.5, R404.3 applies regardless of whether the new garage is exempt from the envelope lighting and or HVAC portions of the NIC. In real life, though, a brand new freestanding one-car garage not using electricity at all is highly unlikely from my review experience. So we just need to make sure to provide the 40 amps to service the electric vehicle. I have another question here. This one is alteration job application. An existing 2-story, 1-family residence is enlarged by alteration and addition to a 3-story, 2-family dwelling, but this job application is not required to meet NB requirement. The existing detached 1-car garage will remain as is, not part of the alteration. Yet, an additional open parking space is planned on site. So we have 2 questions. Is compliance required for the existing garage? And is compliance with this code section required for the open parking space? So the answer is yes and yes. Compliance with R404.3 is required for both the existing garage and the new open parking space. Additional electrical service is called for in this alteration enlargement job application. That is, amperage to the existing electrical panel is increased to service the 2-family residence. This triggers compliance requirement for the existing detached garage for 1 family, and also the new open parking space is required to be electric vehicle service capable for the other family in the 2-family residence. And I think this concludes our presentation for the 2020 NYC ECC How to Guide for supporting documentation. And Duncan will jump in and explain about the bulletins.
So thank you, Jean. We also just wanted to remind you of other additional online resources. So the buildings bulletins are one other area of information that we frequently update. So if we could get the next slide, please. So the 2020-007 Buildings Bulletin relates to alterations and additions to building envelopes, and really only updates the code sections with the 2020 code change. So there's no substantial changes from the past, but it does outline very specific interpretations of the chapters, the additions and alterations chapters R5 and C5 of the New York City Energy Code. Next slide, please. 2020-008 expanded the language regarding how lighting controls are treated in existing buildings, and it added new language for vertical and horizontal transportation and commercial kitchen equipment. Next slide, please. With the 2020-009, which relates to HVAC, there were several key changes. And any deviation from the Energy Code due to existing building conditions described in the bulletin must be indicated in the energy analysis of the construction documents. And there's also a new commissioning section for existing buildings. Now, the trigger for commissioning is connected to load rather than newly installed equipment. And I think that brings us to the conclusion of our presentation. Here are some of the links that we mentioned briefly earlier in the presentation. They're all at the DOB website. You can look under Energy Code, and there's you get the code in full itself, the how-to guide that we were talking about this afternoon, and then the buildings bulletins I just mentioned. And if there's something that's not clear or you'd like clarification on a technical issue, then please email the Energy Code at buildings.nyc.gov email, and we'll try and get back to you within a timely period with an answer to your question. And I think we're on to the questions. Is there anything in the Q&A that we should recap or anything that we need to answer more fully? Bruce and Emily, if you want to jump in there. Let me look. So yeah, we're going to put this session is being recorded, and so you'll be able to listen to it on YouTube. And then we're also going to provide a PDF. And as attendees of this presentation, you'll get notification that the PDF is available. Let's see, where should I start? Oh, somebody's asking, is there a guide document on inspections? I mentioned that briefly. There's going to be a lot of documentation and a video by the Building Science Lab specifically on air testing. That's going to be forthcoming in the fall at some point. Sorry, lots of scrolling. I think yes, when referring to residential, yes, that's for the economizers. That's what I meant when I was talking about residential in that respect. That's for that sort of residential building rather than the specific smaller buildings, 3 stories and less. So I think it's mostly questions about the presentation being available. If anybody wants to type something in quickly.
Seems like some people are having trouble asking questions in here. And just a reminder that we do have an Energy Code email account. So if you didn't have a chance to answer your question here, and you can see the screen now, please reach out.
So it's almost 2 o'clock and brings us to the close. And as Emily just said, if you have questions about the presentation or just technical questions in general, please email us and we can get back to you. And if you have any other feedback, please let us know too. I think that about covers it. So we'll say good afternoon and stay cool.
Thank you everyone for attending and
Thank
for your
you.
interest. Bye everyone.